Love takes many forms: romantic passion, parental devotion, social unity, even destructive obsession, but all emerge from the human brain's neural architecture. The human brain encompasses love, showing that every manifestation of affection is fundamentally a product of neural processes. The neurobiology of human attachments model explains how bonding mechanisms first shaped by mother-offspring relationships become the foundation for all later attachments. The mother-child bond serves as the root, with romantic attachment, friendship, and other bonds branching out, showing how early maternal circuitry is repurposed throughout life. The dopamine system connects directly to reward regulation, controlling our experiences of pleasure and satisfaction. Oxytocin, often called the love hormone, plays a central role in human bonding and physiological processes. Oxytocin influences childbirth, breastfeeding, and bonding, demonstrating its wide-ranging impact on both physical and social functions. The hypothalamus secretes oxytocin, which travels to the posterior pituitary and then enters the bloodstream, completing the hormone's release pathway. Oxytocin triggers uterine contractions, facilitating the birthing process. In the mammary glands, oxytocin allows milk to flow into lactiferous ducts and then be ejected at the nipple during suckling. Skin-to-skin contact, mother-infant interaction, romantic rapport, and sexual interaction all trigger oxytocin spikes that strengthen interpersonal connections. The striatum is where the dopamine and oxytocin systems converge and integrate, forming a key subcortical hub. The synergy between dopamine and oxytocin confers incentive salience, making bonding behaviors feel motivationally important. Affectionate interactions produce psychological gratification, which in turn drives seeking behavior, creating a rewarding cycle that motivates us to pursue connection. She and colleagues conducted a meta-analysis in 2022 to systematically compare brain activation patterns between maternal and passionate love. The analysis included 12 studies on maternal love and 9 on passionate love, drawing from a total of 169 activation foci. Maternal and passionate love share common activation in the left VTA, revealing a shared evolutionary substrate. Maternal love preferentially engages the left VTA, right thalamus, left substantia nigra, and left putamen. Passionate love activates the bilateral VTA, recruiting both brain hemispheres. The left VTA is the co-activation site, showing significant activity across both maternal and passionate love. When statistical thresholds were relaxed, maternal love recruited the left putamen more than passionate love. The VTA acts as a hub in the mesolimbic pathway, secreting dopamine into the nucleus accumbens and triggering dopamine release. This pathway underlies the highs from substance use, sexual pleasure, and food satisfaction, all dopamine-mediated rewards. While the authors did not report activations for the hypothalamus or caudate nucleus in the results section, they nonetheless claimed that involvement of these regions in maternal love indicates oxytocinergic contributions in accordance with the neurobiology of human attachments model. Despite recruiting different brain systems, both maternal and passionate love are anchored to a core evolutionary substratum in the midbrain VTA. These MRI scans show the left VTA at coordinates -2, -22, -14, with intensity values confirming the shared neural substrate across both forms of love. Rinne and colleagues broadened the scope in 2024, examining brain responses to 6 different targets of affection beyond maternal and romantic love. The study explored love for romantic partners, children, friends, pets, strangers, and nature, each producing distinct neural activation patterns. Participants listened to love-eliciting stories inside an fMRI scanner while researchers measured their brain activity. You are in the laundry room with your partner. They are loading the washer with laundry, and suddenly you remember what a lovely person your partner is. You feel love for them. Your child runs to you joyful on a sunny meadow. You smile together and the sun rays flicker on their face. You feel love for your child. You need help moving house and you call your friend. They promise to, of course, come to help out, and soon you are lifting cardboard boxes together in a van. In the middle of the ordinary situation, you feel love for your friend. You are in a park playing with your dog. You toss a stick for the dog and it retrieves it enthusiastically wagging its tail. You love your dog. You see an old woman on the street carrying heavy grocery bags. You help her by carrying one of the bags to her home door 1 block away. The old woman is grateful, and you feel love for her. You are in the archipelago at the seaside. The blue waves ripple over the coastal stones. A crooked pine rises next to you, and there are white, fluffy clouds here and there in the sky. You love nature. The neutral baseline described an ordinary bus ride home, designed to elicit no particular emotional response for comparison. These brain models show regions with higher activation in pet owners compared to controls, demonstrating that personal experience with pets modulates neural responses to animal-directed affection. Different love objects produce distinct neural patterns, showing that the target of affection shapes cortical activation. Interpersonal love engage social cognition regions like the temporoparietal junction and midline structures more than love for pets or nature. Pet owners showed greater activation in social cognition areas when experiencing love for animals compared to non-pet owners. Interpersonal affection activated the brain's reward system more strongly and extensively than love for strangers, pets, or nature. Attachment experience varies with the affection target, showing that cortical activation patterns depend on who or what is loved. Love is a multidimensional construct, with biological bonds like parental and romantic love as archetypes, and sociocultural bonds like affection for animals or nature as culturally shaped forms. Bortolini and colleagues conducted a comprehensive meta-analysis in 2024, analyzing 79 neuroimaging studies with over 2,300 individuals to map the neural circuitry of human bonding. The analysis included 26 studies on own babies, 19 on friends, 14 on romantic partners, 10 on non-child kin, and 10 on child cries. Results revealed extensive co-activation across the inferior frontal gyrus, striatum, basal forebrain, amygdala, anterior insula, and anterior cingulate cortex, regions involved in reward, motivation, social cognition, and salience detection. The affection neurocircuitry integrates midbrain regions, forebrain regions, and executive areas, spanning multiple levels of brain organization. These meta-analytical maps from 79 studies show widespread brain regions involved in human bonding, with intensity heat maps across multiple views and slices confirming the complexity of the functional neurocircuitry. The neuroscience of love reveals a multifaceted phenomenon, and we can now synthesize these findings into a working definition. Love's neural substrate includes the basal ganglia, limbic system, isocortical networks, and the dopaminergic and oxytocinergic systems, widespread actors contributing to attachment. Love is a subjective experience marked by psychological gratification when affective bonds are formed and strengthened between sentient beings, requiring the optimal integration of neurological systems spanning multiple scales of organization. Beyond the technical definition, love has inspired poetic and philosophical reflections across 4,000 years of human culture. An ancient Sumerian love song from around 2000 BCE expresses devotion through sensual and religious imagery, asking for caresses from a beloved protector. Plato described love as an innate drive to reunite separated halves and heal the wound of human nature, making one out of two. Shakespeare observed that love looks not with the eyes, but with the mind, which is why Cupid is painted blind. Kurdish poet Ahmedeh Jani wrote of love as an invisible fire that consumes the lover throughout, whether morning, evening, day, or depth of night. Victor Hugo poignantly noted that for a mother who has lost a child, it is always the first day, the pain never ages, and the heart remains dark despite fading mourning clothes. Dostoevsky captured romantic yearning, expressing the persistent hope of meeting someone despite isolation, dreaming every day of finding love. Nietzsche reflected that we love life not because we are used to living, but because we are used to loving, acknowledging that there is always some madness in love, but also always some reason in madness. This miniature by Hassan Barrows depicts Mem and Zine in a lush forest, visually representing the romantic love theme explored in Ahmedeh Jani's epic Kurdish poem.